Good afternoon, everyone. Welcome to MLOps Production and Engineering, New York 2021, hosted by MLOps World. Our speaker today is Samantha Zeitlin. She's the principal machine learning engineer at Elastic. She was a former cancer researcher with a PhD in biochemistry, where she specialized in DNA damage, cell division, and high-throughput image analysis, in other words, big data. She's been working in software for about 10 years, including stints at multiple startups, Yahoo, and as an independent consultant. The title of her talk today is Deploying Model Artifacts in Hard Mode. If you haven't had a chance to read the abstract yet, I'm going to read it for you because it's lovely. Here's the scenario she presents. You've just started a new job, and the crown jewel machine learning model is becoming stale at a consistent pace. So it has to be retrained and re-released sooner rather than later. The real problem is that training and deploying a model takes 2 weeks, and it's done almost entirely by hand. And the last person who was doing this just left. How do you go about starting to automate this? Oh, and actually, you're supporting 2 products, the new one and the legacy one from the startup that was acquired by the bigger company that you have just joined, which means you now have to learn and automate 2 completely different processes for shipping the same model, but the documentation is, of course, sparse and contains a lot of ambiguous terminology. Sounds very real. The good news is this is a highly collaborative environment, and everyone on the team has been working remotely since the pandemic started. In this talk, I'll share the story. Samantha will share the story of how she rewrote the code to get 7 different artifacts deployed and some of the trade-offs they made to get it done in less than a month. Very impressive. She'll talk about the things they learned the hard way, some things they wish they'd done differently, and how they're planning to make this all easier. Thank you so much, Samantha. We're looking forward to this.
Thanks, Marty. Great intro. I guess I'll just go ahead and start now. Thank you for coming to hear this story. It's been an interesting time since I started at Elastic in May. And I'll tell you a little bit about the company and about the team that I'm on. I'll also give you a little bit of background on, in a little more detail than the abstract did, what was actually going on and the history of this model and the pipeline. If you're familiar with Elasticsearch, then you're probably a little bit aware of Elastic. Elasticsearch is a search and analytics engine, and we also have a bunch of data visualization provided by a tool called Kibana. So our team, which is in the security part of the company, uses Elasticsearch for all of our model monitoring, and most of our dashboards, actually all of our dashboards, are in Kibana. So today I'm going to talk about the security learning product. The security part of Elastic was acquired 2 years ago as a startup called Endgame. And Endgame has this product that detects malware using machine learning. So this screenshot shows essentially how Endgame works from the user's perspective. This is a Windows VM. If you downloaded or otherwise installed a piece of malware by accident, or even on purpose if you're doing QA, you would see this file gets quarantined and you would get an alert that pops up on your screen letting you know what happened. Is entirely powered, or almost entirely powered, by this malware score machine learning model that began as a Kaggle competition submission by Mr. Phil Roth, who was a member of our team. And he did this model with relatively small amounts of data at the time and an XGBoost. The scenario that I walked into then was that Endgame had this kind of flagship model, and because new malware is coming out all the time, it needs to be retrained monthly. There was sort of a pipeline in the sense that there was some existing code, but it all had to be run manually from one person's laptop. And Phil had left a couple months prior. The person who had taken over running the code had begun to try and rewrite a bunch of it, and then that person left. And I joined, and another machine learning engineer joined along with me, Ashton Sidhu, and we've been working on this since then. So Ashton and I had both done this type of thing before, and we had certain expectations. We thought, great, we'll train the model, we'll publish the model, and then we'll just sit back and watch the dashboards, and it'll be great. At the time was that the publishing steps themselves were really involved, and we needed to fix that first. So this gives an overview of just the files that needed to be generated. You can see here on the left, when we finished training the model with AWS Batch and SageMaker, the files get written into S3. We get a model exgb file, as well as a block list, which is things we know are malware, and an exception list, files we know we don't want to quarantine by accident. And then I Dockerized some code with Python that redoes these steps so that we now create two separate sets of JSONs with the correct metadata. So the model gets wrapped, and that's the same for both platforms, but we actually have different sets of metadata that get used for the Elastic lists and then the legacy endgame lists, which unfortunately are stuck on this old blacklist, whitelist nomenclature. And then there's further steps that have to happen. And when I first started, this encryption step was completely broken. That uses a tool that was written in Go. And I had to rewrite the parts that run that from Python and create the encrypted output files and zip them up. There's more steps that have to happen to actually get the artifacts out the door. So on the Elastic side, it's been streamlined somewhat. We take the JSON files out of S3. At the moment, we still have to manually download them to our local machine, run a Python package called Banksy, which was written internally, and that does some amount of validation and opens a PR with manifest updates. We also have to create a separate PR manually for another configuration update to push the model into a place where we can get monitoring on it. And then for the endgame product, we have the encrypted zip that has to be manually downloaded onto a VM on your local machine to run QA tests, where we literally drop malware files on the desktop and make sure that alerts fire as expected or not for things on the exception list. And then we also have a process where we pull the files from Artifactory into the cloud system and run QA tests. And this last time we had to do this all manually because some of this automation was under construction. And then we also have to open 2 more configuration update pull requests. So that's a lot of stuff that has to happen, and this wasn't documented very well. Worse than that, I had never worked with a system like Artifactory before, where it literally told me that my status was successful. I had submitted my file, but then when I went to look for my file, it wasn't there. So that added an additional level of complexity, which was interesting. The highlights of things that I learned the hard way. So we started from a place where just training the model took approximately 2 days. And working with the principal data scientist on the team, we were able to use less data, run the training on fewer nodes, and got it down to about half a day, which is a pretty good improvement. Publishing the code, as I mentioned, publishing the files, the code for that was all stale. And that process alone would take a couple of days, assuming everything went smoothly, because there were so many things that had to be renamed and done manually. So I Dockerized this and added tests and logging, and now it can be run in approximately 10 minutes with a single command line call. In the process of doing all this, we updated the documentation. So now we have READMEs and diagrams, and the consequence of this is that now anyone on the team can run that code. I also realized as I was doing this that any artifact at any time might need to be overwritten if we found that something was missing from one of the lists, for example, and we might have to retrain the model, and it would be easier if we could parameterize everything. Previously, everything in the pipeline depended on configuration files, and it was more problematic to go in and edit those manually in all the places that they needed to be edited. Some were on S3, some were on local machines. It was much more convenient to be able to just pass in a command line argument. And finally, I learned that asking an open-ended question often did not yield any kind of response. So if I asked, hey, does anyone know how this works? Sometimes it would just be crickets. But if I said, I'm going to do A, B, C, I was much more likely to have people come out of the woodwork to tell me, wait, don't do that. B is defunct and you have to do this other thing. Some advice on what not to do with model versioning. I recommend that you don't assign the model version until you've got a release candidate. Found this out the hard way because of the way the deployment works. A model version effectively gets burned once it's in the manifest. So if you're still doing QA during some of this process, or you're otherwise at all uncertain that this is going to be the final version of the model, you would have to back all the way up to the beginning, reassign the model version. In some cases, we actually had to rerun quite a lot of steps in order to recreate the files that we needed, because as it turns out, the model version needed to be not just in the file name, but also internal to some of these files. So the files actually had to be recreated. I also recommend not restricting model version numbers to unwritten requirements. So in one case, I accidentally burned a model version number because I didn't know that we couldn't increment them just one at a time. And the format that's being used right now requires the numbers to increment by very large amounts, which means that if we do switch to doing updates more frequently than monthly, we're going to end up with very large version numbers. So that's something that we need to address. There was also a really interesting F-string problem. As I mentioned, we had a total of 7 different files, and it actually, I think, ends up being slightly more than that. The file names and S3 paths were all being generated as the publishing code ran, which meant if anything went wrong, it was very difficult to figure out where in the code it was coming from, especially without logging. One day it finally dawned on me that what I needed to do was to pull all of that stuff out into a class and put it at the top of the class. So it's all centralized in one place, and it's very, very easy to make sure that all of the naming and paths are consistent and that it's easy to track. I added a lot of logging to make it very, very obvious where these. So for example, the model location being where the file is in S3, and then the model prefix being the, we can then log that. Success message also tells you we successfully wrote this file where we wanted it to go. Here's where we tried to write it. So I think this video on the left does a really good job of making the case for why you don't want to do things like publishing by hand. There are so many things that can go wrong, and each different person who tries to do it will make different mistakes because we all make typos and we don't necessarily know all the things we need to check by eye. And instead, what we really want is something more like the video on the right, where every time publishing just comes out exactly the way we expect. This should be the easiest part of the pipeline. So I'm making the argument that more automation is worth investing time in because it gives everyone more time to do research, to do more research. So the kinds of things that I've added automation for and that I recommend are, adding into your code steps to validate things like file formats, the size of the file, where the file should be. Infrastructure, making sure that the environment is the same. So Dockerizing means that the code should run more or less the same way on my machine or on Astrogen's machine or in the cloud or on Jenkins. And we should be able to transport files, for example, from S3 to Jenkins without someone having to do that by hand. And we should have ways to run tests automatically from our local machines or in CI/CD. Observability means that we can monitor model performance and have alerts that will let us know if anything looks funny. And all of this means that we don't have to spend our time babysitting dashboards or literally renaming files by hand. There's still some manual stuff that's left to do all of that. And it's things like designing and building dashboards, making decisions about business logic, and at the end of the day, still want to have more time to do research. Long story short, what I would do differently if I knew then what I figured out along the way. I strongly recommend if you're embarking on this type of project where you're handling a lot of legacy code, spend as much time as you can looking at the original code and break down the tasks and write them out, because there were a lot more steps than I initially realized, and there were a lot of things that just weren't written down anywhere. And it didn't really become obvious until I started, as I mentioned, proposing what I was going to do and then having people tell me, well, actually, that's not going to work. I also wish I had delegated more, because it really was a much bigger project than it looked. The original code was pretty concise because there was no logging and there were no error messages and there were several steps missing. So there was a lot more that needed to happen than was immediately obvious. So we have a lot of plans and projects in process. What we're working on is improving the dashboards and making them better. We're trying to reduce the number of steps that it takes to get the artifact out the door. So there are a number of projects going on to reduce how many times we have to open manual pull requests in multiple repos, including a project that another team is doing to automate all of the end-to-end QA so that we won't have to manually download malware onto a VM in order to test whether it works. And we have plans to fix the problems with the model versioning. I'm not sure yet exactly what the right answer is here. We may go with some combination of third-party tools and internal code. But obviously, we need to use a temporary model version as long as we possibly can through all of the validation steps. And that includes potentially things like releasing the model in a diagnostic mode so we can check with our customers and see if there's anything that looks like it might be going wrong before we release it for real. And obviously, we need to simplify all the places that the model version gets used. It includes places like all of the configuration files we use for tests that and the dashboards where we track model performance. And I did probably too much of this by myself, but I don't want to give the impression that this was all done by me. It was very much a collaborative, full multiple team effort. And I'm really grateful for a minute here to thank everybody. Past and present members of the security data science team, especially Ashton, who was really instrumental in fixing a lot of problems with the legacy code. Andrew Davis, who's our principal data scientist, who figured out how to make the model run faster and better. Apurva and Disha, who helped with a bunch of things, including dashboards and helping me figure out how the Artifactory files should be formatted. And Bobby Filler, who's our manager. The security data engineering team, which is led by Steve Ross, and especially Jessica David, who does all of our CI/CD stuff. Chris Donaher, who owns the Python packaging tool Banksy that I mentioned, and Hez Cardy and Claire Byrne, which they actually built a pipeline for helping us cache anything that we found as a false positive. Other security protections team experts jumped in, including leadership. Joe Desimone and Mark Dufresne both helped us with manual testing when we didn't know how to do it. Devin Kim, who took care of Artifactory problems. Ross Wolf and Sean Cunningham, who also helped with some of the encryption stuff. And Ashla, who referred me to this conference and this opportunity to tell you this story. And We are also hiring for a senior machine learning engineer, and things are much better now that we've figured out how to solve some of these problems, and we're moving on to more automation for the rest of the pipeline and automating ways to build more models. And I think that's it. And I'll take questions if there are any.
Thank you, Samantha. I have a couple, but I'm going to start with the audience. I hope I'm pronouncing this name correctly. Gian Mario is asking, do you recommend hiring specialized MLOps engineers to manage the automation? Or do you see MLOps more of a team practice done by everybody in the team, including data scientists, ML engineers, and so on?
I think my answer is both. I think the place we're in right now, it's helpful to have people who are experienced with CI/CD and infrastructure to help set up the automation. But longer term, I would like to democratize it as much as possible so that everyone on the team will be able to deploy models more easily. And ideally, we don't have a single point of failure as happened in the past.
Yes, you touched upon it in your future directions. It seems to me there's a real opportunity to build a nice abstraction layer to assist in that democratization and generalize it and have that as a protection against these single points of failure and so on. I guess you've thought about that specifically. And
yeah, so in the past, I've used a tool called Pachyderm that makes it easy for data scientists to Dockerize and deploy models on Kubernetes. So we're probably going to try something like that again here and see how it goes.
I was curious to know, you said you sped up the training of the model from 2 days to half a day. What was the key to that?
I think the biggest piece was using less data.
Oh.
Previously, they were training on all the data that had ever been collected, which was really unnecessary. So we can get by with a lot less data. The other part of that is that since we're using less data, we're able to use fewer nodes, which means we lose less time on I/O. Because the big problem with distributed computation, you're probably aware, is transferring the files back and forth between nodes.
Did you have to play with that to optimize it so that you were getting enough to get the good results, but not using more than was necessary?
So I didn't do that part here. Andrew did that part, but I have done something similar at other places. And yeah, I think it was mostly a question of how low can we go and still get the kind of performance that we're looking for.
Yeah, wow. So it was a data throughput problem.
Mm-hmm.
It's very nice. I look forward to your talk in 2022 when we can hear more about what you've constructed at that abstraction layer. I don't see any more questions. I'll encourage my audience to post something, and otherwise, I would like to thank you very much for sharing your experience and joining us here, and for your insights and taking the time. Thank you, Samantha.
Thank you. Thanks for hosting, Marnie.
Great. Okay, take care.